Hey guys, my name is Shashank Kalanathi, and I'm a data analyst. And today I'm going to show you a little bit of the work that I do just on a daily basis and try and give you guys an idea of what a data analyst job entails. First of all, I wanted to thank you guys so much for liking and subscribing and commenting on my previous video. There seems to be a great desire to see more videos about the actual work that a data analyst does on a daily basis, and I'm happy to oblige. So let's get right into it. Today we're talking about, we're going to be working on a geospatial project. So I work on all kinds of projects, and like very simple geospatial projects are part of like what I do too. Although obviously if things get much more complicated, you do want to bring a GIS analyst. But some stuff is fairly simple. So for this project, what I was asked to do was I needed to find all of a certain type of building within a certain region of a certain city. So I'm going to be mixing up all the details as those are actually private to my client. So let's try and find all of the schools in the general Sacramento area. So how would we do this? Well, there's a couple of things we have to figure out. First of all, we have to figure out where can we get a data set of schools in the Sacramento area. That's, first and foremost what we need to figure out. And we need to figure out what is the actual bounding box, what is the region that we will specifically be looking at. So to answer that first question, we're actually going to be using something called, I think it's like the Bing Maps API. Yeah, so there are a couple of Bing Maps APIs. One of them is this one over here. Maps public places of interest. So one of them is this data set over here. This is a public data set that Bing has that basically shows you the points of interest of all different types of buildings. So I can actually show you specifically what they have. So they have POI entity types. These are the quote-unquote different entity types that they have information on. So, agricultural structures, airports, airport runways, ATMs, city halls, coffee shops, fast food restaurants, gas stations, hospitals, hotels, junctions, libraries. We're going to be focusing on schools today. So let's go down here. I can just use Control F or Command F and look for a school. So we're going to be looking for entity type 8211. And this is actually an API that we are going to be submitting GET requests to in order to actually obtain the data. Okay, so that's one thing that we figured out. Another thing that we need to figure out is exactly how this API works. So instead of going through all the documentation, I'll just give you a basic idea of what it does. We give it a longitude and latitude, or I believe you can also give it an address. And from that longitude and latitude, it will try and find a circle of X kilometers around that and look inside that area. So obviously, if this wouldn't be a problem if I could query a 30-kilometer wide circle, but I can't, at least not accurately. I think I've only been able to accurately query like 1 to 2 kilometer long radii circles, and that's where the next section of the problem comes in. So I could send a bunch of requests to the server and try and cover every little section of a city, but I really want to reduce the number of requests I send. And that's just general good practice. Even if an API you're using is free, you want to reduce the number of requests that you send over, just because that's good practice. It keeps resources free for everyone. And oftentimes you'll be paying for every API request you send, so you want to minimize those as much as possible. So what I had to do is I had to do a little bit of research and see, okay, how do you organize a bunch of circles inside a square? That way you can cover every single section of the square and not miss anything with as little overlap as possible. Now, this is not the mathematically optimal solution, but this is one that was easy enough for me to code up. And obviously, if anyone has like better ideas of how to do this, please let me know in the comments section. I'm always learning. I'm always looking forward to learn. But we have this square over here, and this looks like a relatively easy pattern for me to copy. Basically, what I would do is I would I would start up at the upper left corner, and then I would go I would go 2 radii out, and I could create another circle there. So that would be I would send a GET request at this longitude and latitude, and then a GET request at this longitude and latitude, all the way till the end of the square that I'm looking at. Then what I would do is I would go all the way back to the beginning, and I would go down 1 radius and over 1 radius, and that would be the next one, and then just do the same pattern. Now, what you might notice here is that we have two distinct patterns of circles that we're looking at. We have like this pattern on the first row, which is 3 circles across, and then this pattern on the second row, which is 2 circles across. So I call that my even and my odd pattern, and you'll see me code that up in a second. So for ease of use, I'm just going to use this pattern over here. So there are going to be 3 parts to this that we have to code up. We have to code the logic for pulling the data from the Bing API. We have to create the logic for determining the number of points to pull. That'll be this over here. Basically, what points do we actually pull? So actually, I should retype that. For determining what points we're pulling. And then we need to decode the output. So the outputs will come out in a JSON format. For anyone not familiar, a JSON format is basically a Python dictionary. Python dictionary. In that it is like a key value pair inside curly braces. So you'll see over here, in this Python dictionary, we have a key, the word brand, and then a value, the word Ford. Key, model, Mustang, value. Key, year, value, 1964. That's more or less what a JSON looks like. A JSON is basically this format, so it actually works quite well with Python. The other major format that APIs like to output data into is XML, I believe, but I've heard that JSON is what you really want to stick to if you have an option to. So let's start coding this up. So actually, I tried to shoot this completely unscripted earlier, and like I was just stuttering so much that I actually pre-wrote a lot of the code, and I'll just walk you guys through it. I don't think this is going to be an hour-long video. This will probably be a little bit shorter. So what we're doing here is we're going to have a couple of different scripts, or 2 different scripts and a Python notebook that we'll be running. We'll have our notebook, which we'll be interacting with in order to query our data. Probably we'll have a notebook also to decode the data, or I might just insert that in the same notebook. We're going to have our formulas inside, or functions basically, inside a separate Python file. Let me zoom in for you guys. We're going to have our, as you see here, our formulas or our functions inside a separate Python file. And we're going to have our secrets Python file. And I'll be going over this in a minute, and I'll tell you guys why I believe this is a great Python file to have. I learned this from some guy on YouTube, that this was a great way to, and it seemed like a great solution to a problem I had. So let's first start off with trying to recreate this circle pattern over here. This was actually, it seems very simple, and it honestly probably is not that hard, but I was overcomplicating it. So what we're going to do over here, what I did, is I basically need a bunch of longitudes and latitudes. So what I did is I tried to, if you look at it, all of the x values, these 3 x values over here, are the same as these 3 and the same as these 3. So basically the x values, or the what I believe would be the latitude, no, the longitude, I believe, of these values and these values and these values are all the same. And also the longitudes of these and these are the same. So what I could do is I could create 2 different sets of x values and then cross join that, meaning pair with every other y value from here and here. So these 3 are the same, and these 3 are the same as these 3 and these 3, and these 2 are the same as these 2. So basically, I just have to calculate 4 different arrays or lists, and then I can cross-join all of those lists together in order to get every single point I need to query. So let's go ahead and try that out. I've created a function called mapSplitter, which I'll be calling from my other notebooks, and I found out that this is a great practice. It's if you can try and put your functions on a separate Python file, that way you can reduce the length of the Python file you're actually querying. Separating parts out like this makes it easier to troubleshoot later. So I created x odd and x even. So we're going to call, I believe, this row, the rows with 3 circles inside them, we'll call them x odds, and we'll call the ones with even numbers of circles inside them x evens. And then I need to know what the current point is, and so basically the current point will be set at the upper left corner, and then I iterate through every the x value of every circle going across until I reach the end. So what I'm saying over here is if we're going to ingest, the parameters or arguments we're taking in are the upper left coordinates, the upper right coordinates, and the lower right coordinates. Honestly, technically, you only need two, the upper left and the lower right coordinates, but this makes it a little bit easier for me. So what I'm saying is while current point x, and remember current point is the upper left x value, so while current point x is less than the upper right's x value, add the current point x to our x odd list. Also, add current point to current point x, add this over here is how you convert a longitude or a latitude into kilometers, and then multiply by 2 because we actually need to go like 2 radii over here. So we do that basically until we reach the, like from here all the way to here. And then I tell it to do the same thing for what I call the even row over here. And I'm saying current point x equals upper left, this x value, plus just 1 radius over. That way we get over here. And we do that for our even rows too. I'll go ahead and post this code on my GitHub too. That way you guys can go ahead and take a look at it. And then we do the exact same thing for the y, except we're going down now. And you know what? Let me show you how that works. So I've opened up a new workbook, and I have a Excel file I created that helps me easily build out squares. As if I adjust the upper left coordinates, then the rest of these will turn into squares, and I ingest the values from here. This is a great practice in my opinion. Sometimes it's easier to just use Excel for things, and you can manipulate values in Excel like inputs, and then just tell your Python script to ingest the inputs from the Excel file. So I oftentimes will use Excel files to define arguments in Python because it's easier to just adjust an Excel file oftentimes than it is to adjust like a Python file. But to each his or her own. I've heard the exact opposite from people too. I think it's because I learned how to code informally and significantly after I'd known how to use Excel. So let's see. So we ingested this Excel file here, as you can see. And then we queried these points over here, and then so I should go up here. So in my imports, I said from formulas, so that refers to this Python file over here. Import map splitter and Bing maps queries. Those are two functions we're importing, or methods in our case. And map splitter is the one we just went over. And then when we go through map splitter, it creates all of these points, and you see it creates the same grid pattern that we're expecting. So it looks like it works, which is awesome. That's exactly what I wanted. Although I do want to query fewer points in this for the purpose of demonstration, because we really just don't have to query that many. So maybe if I do this, we'll query about half as many points. Let's see. Let me refresh that. And let's run this. Awesome, that's a lot better. I think we can query even fewer points. We really don't need to query that many points for a demonstration. Okay. Awesome. That's 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's 1, 2, 3, 4, 5, 6, 18 points. Okay, that's acceptable. Yeah, I can deal with 18 points. Obviously, if you're going to query an entire city, you're going to need significantly more than that. I oftentimes will query about 1,000 points per city. But this is all we need for now. Awesome. So we figured out the circle logic. So let's go over here. So we've done this. Done. Now create the logic for pulling data from the Bing API. So this is a simple GET request. So what is a GET request? I want to make sure I define this correctly. So my understanding is you basically oh, okay, so you have a couple of methods over here, but get and post are the two ones I'm most aware of. A get request basically tells a server, hey, like, get me this data, get me this information. Here are some parameters, get me this information. And a post request is my understanding basically just saying, hey, could like post this information in whatever database you're using. So we're going to be using the get method in order to grab data from an API. And I think this is a tremendous and a very, very valuable skill as a data analyst is the ability, like, as you go around, you'll like find these different APIs and these different data sources that you can query. And knowing what these data sources are is very, very useful. So definitely like write these down as you come by them. Ironically, I actually find, or unexpectedly, I actually find that the Bing Maps API usually is more useful to me than the Google Maps API, even though like Google Maps probably has more data. Bing Maps makes their data more easily available to developers. So, and knowing how to obtain data and how to clean data is a very, very important skill as a data analyst. So this is definitely something that you should put in your hat as a skill. Okay, cool. So let us now query the Bing Maps data. So need to switch this environment. We're going to query this data over here. I'm not sure if I'll check that out in a minute. But basically what I'm doing here is I am taking in a longitude, a latitude, a radius, an entity type. That's what we were talking about over here, where schools are 8211. A Bing Maps key. You always need an API key and a base URL. So the base URL is basically just the, as you can see here, the URL we're using to get access to the API. That's just a standard one. And what we do is we actually construct a URL and we turn that into Bing, and then Bing will return to us a JSON file along with a lot of other information, but they'll give us a JSON file. So I'm going to put in a radius. I'm going to put in an entity, 8211. I'm going to put in my Bing Maps key. These are free, by the way, so, you know, definitely try it out. Query component. So basically this is like, what do I want out of the API? Query, this is like putting together the different information we're going to need for the query. So as you can see, I'm just concatenating a bunch of strings together over here of the different information we have. And the documentation has, like, I'm going to post this online, and the documentation has all this information there. So as I said, I was going to like code all of this up for you guys all at once, but I was stuttering so much that it didn't seem like it would have made a great video. And then the URL that we're actually going to submit is the base URL plus our query. And then we do r equals requests.get URL. So we do a get request on that URL. And then we want this one, .json. We want the JSON file, and we want to return that. So I believe I have all of the information we need. Let me go ahead and try to run this. So I need to do that. Okay, cool. Oh, and sorry, I completely forgot to mention secrets.py. So secrets is actually, that's the file I put my Bing Maps API key in. And this is a great technique I found, because what I could do is now I can publish all of this code to GitHub as a public repository, and I can tell it don't sync. So in my git ignore file, I can just not sync secrets.py. That way I can have my API key, which I need to safeguard, with me at all times without actually sending it over to GitHub, and people can still use my code. So secrets.py is a great tool to is a great way of handling like passwords and stuff like that. And what you can do is when you download my code, you just have to create a secrets.py file with the same variable names, and your code will work just the same as mine. I don't want to sync that either. Yeah, I'll just put that CSV in there. Okay, cool. So we'll publish that onto GitHub, and that'll be available for you guys. I'll see if I can put the link in there as well. All right, so no module named requests. Okay, what am I using? I believe I'm using the right. So I sometimes have problems with, you know what? My environments. I know which environment I need to use. I need to use my web scraping environment, in which case I can't do any plotting. So Python environments are a tremendous way for you to help organize all of the information that you are, or to organize all the different libraries that you'll be using. So I have like my web scraping library, my minimal data science library, my TensorFlow library, sorry, not library, environment. And these environments all do different things. Sometimes it's just a problem of like remembering what goes where, but generally speaking, it's a great way to segment out my work and make sure that I don't have too many package conflicts. I probably should make a mega environment that just like does like everything I needed to, but we're not going to do that today. All right, cool. We have our 18-ish points. Now let us run. I'm basically telling it to save the Bing Maps query data into just this area over here. Entity input not defined. Okay, so this should be entity input. You can only concatenate str to string, not numpy. Okay, so where are we doing that? Oh, correct. So I actually need to, I believe I actually converted all these to strings in this section over here. So basically, when I construct my URLs, I like to use strings. That way no information is lost in transmission. And then the server I'm sending information to won't be able to tell the difference. All right. I think that should solve that problem. So what do we have that is not a string? Bing Maps key, that should be a string. Base URL is definitely a string. So let's start testing each of these out. So I want to take the type of, what is I0? Okay, so that's where we have our problem. So I in query points. Okay. So, sorry, this isn't supposed to be a string. So I can get rid of this. What I need to do is I need to go back here and convert each of these into strings. Now, where do I do that? I think I do it over here. str. So what I'm doing here is I'm making sure that the points, those query points that we output, they're all strings. Let's refresh that and then import everything again. Because what happens is when we imported the old one, Python's just going to remember the old file even if I've already saved over it. At least I believe that's how it works. All right. Okay, looks like it's working. Awesome. So we're outputting these files over here. And then what I need to do is I need to tell GitHub to ignore those files. So what happens is now I'll show you guys what we have here. See if we can get one with some data in it. Most of these won't have any data inside it because most areas won't have like a school there, but I was hoping at least one of them would have it. You know what? Okay, cool. Oh, sorry. You know what? Here's a great way to test if which files have. So what happens is when I query an area, right, it's totally possible there are no schools there, in which case I'll get a JSON file back, which is almost empty. Basically, there's no information. There's very little information inside it. And so a technique I use to see, like, okay, about how much of what I'm returning is, like, empty or not, is I go to... Oh, whoops. I go here, and I take a look at these file sizes, and I'm like, oh, okay, so that's probably a completely empty file. Or, sorry, that's probably a completely empty file. And as you can see, the results are 0. But at 750 bytes, looks like we have some data. And at 3 kilobytes, we should have quite a bit of data. So this probably queried somewhere in the center of Sacramento. So we're going to bring in this text file specifically and parse out that data. And I already have the logic to get one of these. So let me go ahead and pull that for you guys. That way I can just copy and paste the code. And this is the kind of stuff that you'll be asked to do as a data analyst. Obtaining data is a very important part of the job. And let me know if you guys want any more of these tutorials. I like to think they're helpful in showing you guys like what my daily life is. This is another one. These problems are more interesting to me, where they basically say like, hey, find all this stuff. We're not going to tell you how to do it, but figure out how to do it yourself. Because it gives you a lot of freedom to, like, define the objective and how to get there. Okay, I believe I have the code I need. So let us try this. So the with statement is a staple of opening things like JSON files, because what it does is it'll automatically close your file stream after you're done with it. So we're gonna, I believe it was number 17 where we were gonna open, right? If I remember correctly. Real estate. Number 7, my bad. So present working directory plus, I think it's just 7.txt. I think that's about it. Awesome, great job. We got our data. Okay, cool. So as you guys can see over here, this is this is a list of dictionaries that we're getting. So what I can do is I can convert this to I believe I can convert this to a data frame by just doing pd.data frame and then passing in. There we go. And as you can see, we automatically converted this into a data frame. And you can see we have the name, the latitude, the longitude, the address line, locality. We have all this juicy information about these schools, and even stuff that may that may not traditionally be considered a school. And guys, thank you so much. That is just a quick look at one of the tasks I've done as a data analyst. I tried to make this video a little bit shorter than the last one, mostly because I wasn't cold coding everything. I really want to go back to cold coding something because I really do enjoy it. It helps solidify knowledge in my head. But this was just one of those tasks that I think was a little bit too complicated for me to just do and explain at the same time. So if you liked what you saw, please like the video, please subscribe to the video. Feel free to connect with me on LinkedIn, and I really hope to put out more of this stuff for you guys. So any comments, subscriptions and stuff, that really pushes me to make more of this. Thank you guys so much and have a great day.